This circuit here is an interesting and a relatively common way of biasing a transistor directly to the saturation region. How do we know that? How do we know that it's in the saturation region? Well, you'll notice that the drain and the gate are tied together. So V sub D equals V sub G. And we know that in the saturation region, VDS must simply be greater than VGS minus VT. So in this situation, the voltage of the drain is not only greater than the voltage of the gate minus the threshold, it's actually equal to, or VDS is actually equal to the voltage at the equal to VGS, or the voltage at the drain is equal to the voltage at the gate. So it's in saturation. And we want to find a value of R such that this voltage here at the drain equals 0.8 volts. By that, again, because the drain and the gate are shorted to each other, we know then the voltage of the gate, V sub G, is also equal to 0.8 volts, which means then that VGS is equal to 0.8 volts because the source is shorted to ground or tied to ground. Now we've been given all of the physical parameters of the transistor and told to neglect the channel length modulation. Lambda is equal to 0, in other words. So we can calculate the current, and given that we know that the voltage here is going to be 0.8 volts, we'll know that the voltage across the resistor is 1.8 minus the 0.8, or 1 volt. If we can calculate the current, which we can, given what we've got, we'll then be able to calculate the value of R. So we know then that it's in the saturation region, therefore I sub D is equal to 1/2 times K sub n prime, that's just mu sub n COX, which in this case is 400 times 10 to the minus 6th. W over L, well, W is 0.17 or is 0.72 microns, and L is 0.18, so W over L is going to be 72 divided by 18. And let's see, we've got VGS is 0.8. Let's just calculate the overdrive voltage. VOV is equal to VGS minus VT. VGS we've already determined to be 0.8 volts, and we're given V sub T is equal to 0.5. So VOV then is equal to 0.8 minus 0.5. That equals 0.3 volts. So we can go ahead and plug into our equation here. VGS minus VT, that's the overdrive voltage of 0.3 quantity squared. And you go through and calculate I sub D, and we find that I sub D is equal to 72 microamps. Therefore, we can calculate the resistance value. That's going to equal the voltage, 1.8, the voltage here minus the voltage of the drain, which is 0.8, divided by the current of 72 microamps. And it turns out that R will equal 13.9 kiloohms. That's a K. 13.9 kiloohms.